Chapter 14, Number 44. You are heading towards an island in your speedboat when you see a friend standing on shore at the base of a cliff. You sound the boat's horn to get your friend's attention. Let the wavelength of the sound produced by the horn be lambda 1, the wavelength as heard by your friend be lambda 2, and the wavelength of the echo as heard on the boat be lambda 3. Rank these wavelengths in order of increasing length. Indicate ties where appropriate. We have some waves that are emitted here at what I'm going to call frequency 1. They are received at frequency 2. They are emitted back again at frequency 2 because echoes are the same frequency, and then they are received at frequency 3. I'm using frequency because we did the Doppler effect in terms of frequency. It'll be easy to turn it then into wavelengths once we're done. All right, since the range is closing, in the first case, we get that F2 is greater than F1 because we know that the Doppler effect says if two things are getting closer, then the frequency is, as perceived, is higher. And then notice that the range is still closing when we have F2 coming to F3, so we have that F3 is greater than F2. Because again, even in this case, the range is closing, right? It's getting closer. So that means a higher frequency by Doppler shift. So we can put those together and we can say that F3 is greater than F2, which is greater than F1. But of course, we know that the wavelengths, we'll have that the wavelengths are related to the speed by the frequency is lambda f. So a large frequency is a low lambda. So that tells me that lambda 3 is less than lambda 2, which is less than lambda 1. You might remember that this is essentially the same process as is used in Doppler radar, although the shift formula is different, the sense is the same. When something bounces off, we get a double shift.